complicated, much more subtle logic to the structured data that's becoming available. And then really integrating that tightly with workflow using machines. And I think some of the examples we saw were kind of looking back and saying, using today's technology on to create and solve old problems with old approaches. What Sergio is going to show you is how, in talking to some of our customers, we've looked at some of the new technologies coming online with FHIR, looking at some of the problems that we continue to hear our customers talk about, and demonstrating how we can almost, through the current technology and the abilities that are out there and the kind of advanced machine logic, kind of do these mashups of end-to-end processes in a payer organization and show how, complicated problems can actually be addressed with solutions that make the lives of the people involved much more simple. So with that, Sergio, I'll turn this over to you.
Thanks, John. So yeah, I picked up a use case, the member enrollment use case, which is with the addition of the peer-to-peer mandate is getting, or is going to be getting, extended. So what you see on the screen is kind of the beginning of what is kind of traditional enrollment process, where the employer or broker is sending enrollment data to the payer's EDI gateway. That enrollment data is getting processed and then is ultimately pushed into the membership system. In the case of so-called system-to-systems peer-to-peer interaction, if the enrollment data contains consent and it contains the information about the member's prior payer's information, then the peer-to-peer process can also start at the same time, whereby the previous payer is getting contacted, the medical information for that member is getting retrieved, pulled, inspected, and then ultimately pushed into the FHIR server. And this, of course, is a great opportunity for payers nowadays to use that new data for their value-based care, or at the very minimum, push it to the care management team to, in case if members have been flagged for additional review, or some additional new information has been obtained that may warrant this. So at the surface, it doesn't look that complicated. And in case of a happy scenario, when things flow seamlessly, if you were to track this transaction end to end, I mean, here's an example. Features Acme Employment Agency that may be sending this to the health plan in a 34 file, and it shows kind of the end-to-end tracking of this transaction. So it may be getting in the EDI gateway, it gets in format validation, everything is accepted. Then it's this information is submitted to the membership system. Then the peer-to-peer exchange is happening, and then in the end, everything is processed. Everything is nice and dandy. However, of course, life is not that simple. There could be multiple what we call exceptions or deviations from the happy path. And starting with the EDI gateway, there could be your traditional problems related to enrollment data issues. In the peer-to-peer exchange, there could be connectivity issues. It could be issues related to the data itself received. And then as this data is received and pushed into FHIR server, there could be also data integrity issues, things that may not add up. And finally, of course, the new data could be used to flag the members for additional review and potential enrollment into care management process. And organizations today may deal with these exceptions or failures kind of in an ad hoc manner. But the better way to do it is actually to put an exception management framework in place. And the framework is essentially, it's kind of a structured process where the first step, of course, you identify the exception. Maybe initially, as these things happen, you just put them in this framework. So you identify the rules, how this exception come to be. Then you think through, the rules. What does it take to resolve this exception? And it may be as simple as somebody just looking at it and doing it, or maybe automating it eventually, or it could be a series of steps that it may need to go through from person to person or from person to systems and another person. So it's kind of think of like a workflow process. And then, of course, if it's involves manual process, then appropriate people need to be assigned, which then they resolve this exception. But again, think of it, this has to be coordinated. Sometimes may be needed to be coordinated across multiple people. So the systems may need to be monitored and automatically kind of handed over from person to person or person to system. And then as multiple of these exceptions occur, you should be able to monitor and observe the typical resolution path and potentially improve upon the process, eventually completely automating it. Now, I'm kind of on the right-hand side, I can also listed some of the supporting functionality that we need to have this successful. So you need to have, first of all, ability to have tasks and proper task status tracking, user assignment. Depending on the type of exception and type of task, you need to have proper queues, work queues for this assignment, or for different people or teams to be routed. As you kind of go through these tasks and maybe you observe some repetitions, you may need to have some kind of a bulk actions where instead of doing one by one, you maybe need to do some of the actions on a number of these tasks at once, again, to kind of semi-automate some of these processes. Like I mentioned, you need to have some activity coordination between if there are multiple teams involved. And ultimately, you need to have some kind of monitoring dashboards to observe avenues for optimization and ultimately automation of these processes. So let me give you some examples. So let's start with the enrollment data issues. So in this process, the first step when the enrollment data comes in, there could be enrollment data issues. And let me give you an example. So suppose that a file came in, and through your kind of transaction tracking software, you observe that this file has a number of errors, and it has actually a high number of maybe invalid plan ID. So let's say the employer has sent the enrollment transaction, but indicated wrong plan IDs. So one way to do it is, of course, you can start opening the file and modifying it, but a better approach is actually using the exception management framework. You create essentially a task for people to go and correct them in a structured manner. So this, and from the tracking perspective, if you were to look at the transaction, you would see kind of, okay, the transaction came in, it was rejected in the validation, so it went sent to the correction, the exception management framework. So right now the status of this transaction is kind of an exception state. It's sitting waiting for somebody to take action on it. So internal people could, of course, now if this is tracked in a structured manner, there is tasks in the system. So people can come in and either assign themselves or can search for these tasks. So here's an example of I'm searching for some tasks, and I'm searching for this error invalid plan ID. And I get a number of these tasks. I can open one of them, inspect it. See, here's kind of DDI data, here where the problem is. So I can identify, okay, so I need to set maybe this health plan policy number to some specific value because it came from this specific employer. And I can do one by one, but better yet, like I mentioned, I would rather utilize bulk action. So I can maybe start a job where I select all those tasks, assign it to some person, or to myself, and I can do this automated update of all these tasks, and I setting some specific policy number. And then once I'm making this change, I'm essentially releasing all these transactions back into the flow so they can proceed with their normal processing. After completing, so again, what you can see here is kind of a little bit of automation. So instead of doing one by one all these different corrections, I can do maybe a number of these corrections at once. They're both saving time. And then, if I were to inspect the status or the end-to-end tracking of this specific transaction, I would observe, yeah, it was rejected, it was sent to correction, then everything was fine. Then, after it was corrected, it was submitted to membership system, and then went through the peer-to-peer exchange, and then finally processed. And then, of course, as you do a lot of these corrections, you are gathering information. So by gathering information, then you're essentially getting the avenue to be able to automate some of this, maybe completely eliminate human intervention here. Maybe, we could be a simple rule for all transactions that come in from this employer, if it has this, invalid plan ID error, maybe just, automatically set this plan ID to this value and kind of move on. So that's kind of an example of exception as it pertains to enrollment data. If I were to look at the member clinical review, so the transactions after going through the peer-to-peer process, they may land into Fire server, and obviously you would need to have some kind of a rules engine to run and inspect all that data and maybe flag for inconsistencies. And again, initially you may need to have some clinician or some person look at that data. Obviously, you will need some kind of a tool to be able to look into data that is stored in the Fire server. By the way, with the advent of the Fire server, it's a great opportunity now that not only data, you have data maybe in your various backend systems, but now you have actually consolidated place where this clinical information is stored. So you can either choose to also push this data to other systems, or you can actually work on it and inspect it right here in the Fire server itself. So using some kind of a tool, once the patient was flagged, clinician may actually look inside the Fire server and look at the data. So here is an example of a patient record that may be residing at the Fire server, and the clinician may look at some of these maybe conditions. So he sees, okay, there is asthma was detected. This is the information that came in from a prior payer. So okay, do I need to enroll this member maybe in a care management program? Or maybe there is a procedure, physical examination following birth, but I'm looking, this person is actually male, 55-year age old, so things doesn't add up. So something is wrong with this procedure that I received from the previous payer. Again, do I need to maybe clean up this data, or do I need to take some action on it? So again, here you can see kind of a hybrid where the automation is trying to identify these cases and bring into the human attention, but it's still human is still involved. And as you resolve these cases and you see patterns, you can further automate these cases and maybe completely eliminate humans from this process. Let me move on to another use case, peer-to-peer issues. So as the peer-to-peer process unfolds, obviously there is going to be there's going to be issues, and some of the issues that we foresee is going to be at the very minimum some connectivity issues. Maybe I'm making calls to the prior payer's Fire server, and I cannot connect to it, and I repeatedly cannot connect to it. So then maybe some people need to be involved, or I'm getting some data from that Fire server, but again, that protocol is not quite successful, and I'm getting invalid data. It's not compliant. So again, I need to do something with that. So in order to monitor this process, you probably will need, first of all, some kind of a dashboard. So let's say there's a dashboard that shows for a month, how many members were processed that I need to monitor. So for that period of time, maybe the bulk majority of those members were processed okay, but there is some members where maybe I got some invalid data, or maybe there was no loss of connectivity, but the system automatically retires. So those kind of, maybe I'll let them kind of try to resolve on their own, and maybe after a while, if those I keep retrying and I get no response, maybe they failed. So the next step, of course, is for me to go and drill down and analyze and see who are maybe the offending pairs. So if I were to drill down into those failed ones, I can say, okay, well, maybe these two pairs are the ones that consistently have failures. Maybe these are the employers that are getting affected by this. So now, but with this new insight, I can start taking action. And as maybe I'll take this action repeatedly and I record this information, again, there is a great avenue to further automate this process. Or maybe, maybe it's about, communicating with the pair, or whether it's maybe increasing the number of retries or whatever, what have you. But by observing the type of resolution action that been taking place and that are done manually, and if these things are happening again and again and again, this is essentially a great avenue to further automate this process. But this is, of course, in order to do that, you need to have full visibility into the transactions, into what's happening behind the scene. You need to have proper monitoring tools to achieve that goal. And so I gave you some examples of things that may go wrong, but there sometimes you can also review the data that comes in, and again, this is where the ability to track everything end to end, what happens. So here's an example of I'm getting some invalid data from the pair, and actually I need to go and inspect what exactly came in, what happened, how it was posted. Well, in this case, actually, it was okay, but if it were problems, I would get to see the errors, and again, trying to resolve those issues. Now, moving beyond automation, I would go even to the next step is optimization. So again, coming back to peer-to-peer relationships, well, imagine that I keep getting some information from the employers, and the members actually indicated their information about their previous employers, but I don't have those employee relationship established. So one way to track this is by doing another type of automation. So instead of trying to chase those cases one by one, you can maybe create an edit and put an edit in place where during the 34 or the enrollment data transaction processing, if you see a flag that the member have given their consent, and you actually see the information about the previous previous payer, you could try to create a so-called error, what we call informational error, which doesn't stop that transaction, but you still kind of record that, for your information purpose. And you can even put them in separate category, no peer-to-peer relationship, and you can start observing, as these transactions unfold, what happens. So here's an example of a dashboard where I'm looking at the member maintenance. I'm actually specifically looking at this no peer-to-peer relationship category of this transaction with severity information. So I'm seeing, during this time period, there were 1,700 members processed, which gave their information, but I don't have any relationship established with those pairs. And maybe it's an avenue for me to actually go proactively, and I can see there is 4 pairs that I don't have relationship with, but they keep showing up on those transactions. So by looking at these numbers, maybe it's an avenue for me to go and proactively try to establish that relationship up front if I haven't done that yet. So this kind of automation allows me now to not just fix issues, but actually optimize my business processes. So maybe this plan is there is a low number of these occurrences. Maybe I have some other higher priority, but this probably I should start working on them. So now my quest to establish that relationship, I probably should go and find or some kind of maybe public directory of these endpoints. There is EKH Core that maintains these public endpoints now. So you can find that maybe pair on that public endpoint, and you can start going through the process of establishing relationship with that pair, and eventually kind of maintain that list of endpoints along with, of course, their connectivity information and whatnot. So here's an example how you can maintain those. So after establishing those relationship, and you go back to the dashboard and you start observing the numbers. And did the things improve? And this could be a continuous process where you, as you tackle these pairs one by one, and you go on kind of to the next and to the next. You can also, of course, with these monitoring tools, not only see kind of the information what's happening now, but you can also see the trends over time. And you see, well, maybe these things are kind of going away, or maybe, actually see an uptick and these things are growing in the severity. So maybe I should be taking, some proactive actions kind of upfront. These are just some examples of the automation. I kind of maybe went quickly through these examples, and I will open up the floor for questions.
Well, thank you, Sergio. That was a great presentation. I think what we were trying to show here, thinking about, when you hear about AI in healthcare and you think about some of the pitches made by Google or IBM Watson, and the idea that they were going to cure all the world's diseases and replace physicians with machines, I think we saw as in chess, the chess champion isn't gone, but that the real promise of AI and ML and this automation in healthcare is really around, I think what Joe Hostag earlier had said, is in grabbing the low-hanging fruit. And I think what we're trying to show here is that there's an awful lot of places where we can do what Gartner called hyper-automation or human augmentation in healthcare by just leveraging the data, leveraging tools. Most of you out there have lots of tools for EDI and for FHIR and for parsing and business process management, similar to EdFX. We're certainly not the only tools on the planet that can do that. But I think the idea is, as earlier in the day, Viet had said, now that you've got all this data, what are you going to do with it? And I think what Sergio is trying to show here was, here's some examples of what we're working with customers to actually do with that data, to automate, to do human augmentation, to apply the principles of machine learning and AI, and hopefully work with our customers to take it to a new level. So looking here in my session, I'm not seeing any questions popped up. Michael, am I looking at the right windows, or do you see anything out there?
Yeah, I don't see any questions either.
Okay, well, if you do have questions, or if you want to follow up any more, EdFX is running an Ask Sergio session. It'll be tomorrow afternoon. The link and the registration is over in our registration booth, and you should feel free, if you want to dive into this a little more deeply directly with Sergio. He'll be live and online and available to answer any of your questions. So with that, Michael, I think what we've got about about 20 minutes here. Are we thinking we'd take a break, or I'm not sure if Carol McCall is available to start early.
Yeah, how about we just stretch those legs, take a quick stretch break, review your agenda. Our next session's at 3:30. Accelerating the development of AI solutions for predicting patient health outcomes with Carol McCall, Chief Health Analytics Officer with Closed Loop AI. They are the recent $1 million winner of the CMS Innovation Center AI Challenge. So we'll see everyone back at 3:30.
Thank you very much.
Thank you.